Hey physics fans, this is a good projectile question. This is from the projectile package. It's on page 10, number 19 from physics 11 on Fizzix-Alpha. It's a planet, Fizzix-Alpha. A ball is thrown with a velocity at an angle, but I'm helping you right now. It's broken into its two components. The horizontal speed is 16 meters per second and the vertical speed is 8 meters per second up. The ball is tossed from the top edge of a cliff that is 110 meters in height, and the acceleration due to gravity is 12 meters per second squared. What is the final vertical velocity, time, how far from the base of the cliff, what's the final horizontal velocity, and what's the final velocity? So there's lots of stuff. Let's try to fill in this whole table. Okay. So let's get it a start, and let's make sure that we understand it's not the 9.8. We're on a different planet here. It's 12, and it's down, if we want meters per second squared. The initial speed is 8, and it's up meters per second. And the horizontal is 16. 16 meters per second. And it's going to land at a cliff at the base, below a cliff of 110 meters in height. So let's use this box as it's projected up, and it lands down, boom, at the base. And this cliff is 110 meters in height. Okay, and it started up at 8. So we're going to get the final velocity. Vf squared is equal to Vi squared plus 2AD, and Vi is going to be 8, and that's up, squared, plus 2 times 12 down times 110, and that's down. Both are down, so this is going to be a positive term. This is always a positive term. And let's see how easy this will be. So the square root of 8 squared, which is 64, plus 2 times 12 times 110 is exactly 52. That's why I'm not doing it with trig right now. So that's Vf. That was still Vf squared. And the change in velocity is 8 up and 52 down is 60 meters per second. Okay, and that's just Vf minus Vi, but that's the change in velocity, and Vf is 52 down and minus 8 meters per second up. Okay, and that changes 60. So the time is delta V over A, and that's 60 over 12, which is 5. So we've figured out this is 52 meters per second down, and this time is 5 seconds. Okay, in 5 seconds we could calculate that distance, which is just 80 meters, but we don't need to do that. I just did that as V is equal to V times T. We're not asking that question. And last but not least, it's asking for the final velocity. Notice it's not saying vertical, it's saying horizontal, it's just saying final velocity. So it's clear. And the final velocity, well, it always has this horizontal, and it'll have that final. So draw the horizontal first, always do that, because then you're always measuring the angle from the horizontal, and that's what we need. And then it's down. This is 52, and this is 16. Not draw the scale, obviously, because this is 4 times bigger than that. And what we're trying to find is this hypotenuse. And to label that hypotenuse, we want to label it from the horizontal one. Whoops. Okay, that's just the video ending up. That's what was happening there as I was posting it. And so that's from the horizontal. So we need that angle, and we need the length of that, and that labels that vector. So we have to go, the length of that vector is 52 squared plus 16 squared, all square rooted. That's the length. And the inverse tan of the opposite over the hypotenuse, always the y over the x, because we were labeling it from the horizontal, so that's always going to be the opposite, which is the y. Always. Sweet. Okay? So, square root of 52 squared plus 16 squared. And we do the inverse tan of 52 divided by 16. And then we just take those two numbers. So it's going to be 54.41 meters per second at an angle of 72.90 degrees below the horizontal. And that's it. Ta-da! Thanks for joining me. Hope this was good learning on your part and checking out your answers. And thanks. Subscribe. Smash that like button. And yeah. And comment below, as they always say. Thank you. Bye-bye now.